On a crisp July evening in 2025, a telescope in Chile's Atacama Desert caught a fleeting glimpse of something extraordinary, a streak of light slicing through the cosmos at a staggering 130,000 miles per hour. This was no ordinary comet or asteroid born of our solar system. This was 3I/ATLAS, the third confirmed interstellar visitor to grace our skies, a cosmic wanderer from the depths of the galaxy. Its arrival wasn't just a scientific marvel, it sparked a cascade of questions, intrigue, and whispers of secrecy that reached far beyond the observatories. As astronomers marveled at its alien trajectory, something else was stirring. Quiet, calculated moves by the US Space Force, shifting launch schedules with no clear explanation. Why now? Why this moment, when a celestial stranger was hurtling toward us? Buckle up, because this story is a wild ride through science, secrecy, and the stakes of our future in space. Stick around to uncover the chilling truth behind this interstellar mystery, and let us know in the comments what you think is really going on. Picture this, it's July 1st, 2025, and the Atlas Survey Telescope in Chile locks onto a faint dot moving against the starfield. At first it seems like just another speck in the vast cosmic canvas, but as astronomers crunch the numbers, their jaws drop. This object is screaming through space at twice the speed of anything we've ever tracked. It's not looping lazily around the sun like our local comets. It's on a hyperbolic trajectory, a one-way ticket from interstellar space. Named 3I/ATLAS, this visitor is only the third of its kind ever confirmed, following the enigmatic Oumuamua in 2017 and 2I/Borisov in 2019. With only 3 interstellar objects detected in human history, spotting one is rarer than a double lottery win. So why did this cosmic rarity coincide with a mysterious shift in the US Space Force's tightly choreographed launch plans? This isn't your typical space rock. 3I/ATLAS is a rebel defying the rules of our solar system. It moves in a retrograde orbit, backwards compared to the orderly dance of planets and comets around our sun. Its speed is mind-boggling, clocking in at 130,000 miles per hour, fast enough to cross the distance from New York to Los Angeles in under 2 minutes. As it barrels toward the sun, it's shedding a glowing coma of dust and gas, a cosmic tail that stretches millions of miles. NASA's Hubble Space Telescope captured it on July 21st, 2025, revealing a dazzling display that sent shivers through the scientific community. But it wasn't just the comet's beauty that grabbed attention, it was the timing. Months before its discovery, in April 2025, the Space Force made a cryptic adjustment to an Atlas V rocket launch. Weather issues, they said, scheduling conflicts. But to seasoned aerospace insiders, those excuses felt like a flimsy cover for something far bigger. What makes this moment so gripping? The Space Force's launch schedules are planned with surgical precision, down to the second. A sudden shift is rare, and an unexplained one is practically unheard of. Yet, as 3I/ATLAS was racing toward us, the military's most secretive operations seemed to pivot in perfect sync. Coincidence? Or did they know something we didn't? Let's dive deeper into this cosmic puzzle and explore what might be at stake. If this story of interstellar visitors and hidden military moves hooks you, drop a like and share your thoughts below, because we're just getting started. Rewind to April 2025. The US Space Force, the newest branch of the American military, is prepping for a high-stakes Atlas V rocket launch. These missions are the backbone of national security, deploying satellites that guide everything from GPS navigation to global communications. Every detail is meticulously planned, from the launch window to the orbital trajectory. But suddenly, without fanfare, the schedule shifts. The official explanation? Vague mentions of weather and range scheduling conflicts. To the untrained ear, it sounds routine, but to aerospace reporters and industry insiders, it's a red flag. The Space Force doesn't just change plans without a rock-solid reason, and they certainly don't stay quiet about it. Here's where things get juicy. The Space Domain Awareness System, America's cosmic watchdog, is always watching. This network of radars, like the space fence on Kwajalein Atoll, can track objects as small as a baseball anywhere in near-Earth space. Satellites, debris, asteroids, and yes, interstellar comets like 3I/ATLAS are all under its unblinking gaze. The SDA doesn't just observe, it predicts. It calculates trajectories, flags potential collisions, emissions and protects billions of dollars in space assets. When 3I/ATLAS entered our solar system, those radars lit up, tracking its every move. By April, it's entirely possible the Space Force knew something was coming, something fast, unpredictable, and unlike anything they'd faced before. Why the secrecy? Military launches are high-stakes operations. A single misstep could jeopardize $1 billion satellite or disrupt critical infrastructure. Imagine launching a spy satellite only to have it shredded by a fragment from an interstellar comet. At 130,000 miles per hour, even a pebble-sized piece of 3I/ATLAS could become a hypervelocity projectile, punching through metal like tissue paper. The Space Force's silence suggests they weren't just avoiding a risk, they might have been using it. Some analysts speculate this was a live-fire exercise, a chance to test the SDA system against a real interstellar threat, not a simulation, not a drill, but the real deal. If they were training for a cosmic worst-case scenario, they'd have every reason to keep it classified. Revealing too much could expose the limits or the staggering power of America's space defense capabilities. So what's the real story? Was this a routine delay, or were military planners seizing a once-in-a-lifetime opportunity to test their systems against an alien invader? The timing is uncanny, and the stakes are astronomical. Let's keep digging, because the truth might be hiding in the comet's glowing tail. If you're as intrigued as we are, hit that like button and let us know. Do you think this was a coincidence or something more? Let's zoom in on 3I/ATLAS itself, because this cosmic traveler is rewriting the rulebook. Unlike the comets and asteroids born in our solar system, 3I/ATLAS hails from a distant star, carrying secrets from a stellar nursery we can only imagine. Its retrograde orbit is a cosmic anomaly. Objects don't just flip direction in interstellar space without a reason. Something somewhere billions of years ago set this comet on its backwards path. Its speed is another jaw-dropper. At 130,000 miles per hour, it's not just passing through, it's practically fleeing, as if chased by the ghost of its ancient origins. As 3I/ATLAS approaches the sun, it's putting on a spectacular show. Solar heat is sublimating its surface, turning frozen gases into a shimmering coma that glows against the void. By August 2025, the European Southern Observatory's Very Large Telescope confirmed a tail stretching millions of miles, a trail of cosmic breadcrumbs from another star system. But it's not just pretty pictures. The chemical makeup of this comet is a revelation. Unlike our solar system's water-rich comets, 3I/ATLAS is packed with carbon dioxide ice, a signature of formation in temperatures colder than anything in our cosmic backyard. Its isotopic ratios, carbon, oxygen, nitrogen, could reveal a chemical fingerprint from a star system with entirely different rules. This isn't just a comet, it's a time capsule, a snapshot of a distant corner of the galaxy delivered to our doorstep. The scientific community is buzzing. Every telescope on Earth is trained on 3I/ATLAS, capturing data that could redefine our understanding of stellar formation. Is it older than our sun? Younger? Did it form in a chaotic nursery of colliding stars, or a serene cloud of primordial gas? Each fragment it sheds is a clue, a piece of a puzzle that spans light years. But while scientists chase answers, the military is asking a different question. What happens if this comet's debris becomes a threat? That glowing tail isn't just beautiful, it's a potential minefield, a cloud of hypervelocity particles that could cripple satellites or derail launches. The Space Force's quiet maneuvers in April start to make sense. This isn't just about science, it's about survival in a cosmos full of surprises. What do you think 3I/ATLAS is telling us? Is it a harmless visitor or a warning of what's to come? Drop your thoughts in the comments, because this cosmic mystery is only getting deeper. To understand the weight of 3I/ATLAS, we need to look at its predecessors. In October 2017, astronomers in Hawaii spotted Oumuamua, the first confirmed interstellar object. It was a cigar-shaped enigma, accelerating away from the sun without a visible tail or gas emissions. Scientists scrambled for explanations. Solar radiation, hidden outgassing, nothing quite fit. Oumuamua was a cosmic riddle, defying physics and leaving us with more questions than answers. Then, in 2019, came 2I/Borisov, a more traditional comet with a tail and dust. But its chemistry was alien, with water ratios and carbon monoxide levels that screamed, "Not from around here." It formed in a stellar environment unlike anything in our solar system, challenging our assumptions about how planets and comets are born. Now, 3I/ATLAS takes the strange strangeness to new heights. Its retrograde orbit, blistering speed, and CO2-rich composition make it the oddest visitor yet. 3 interstellar objects in 8 years, each weirder than the last. Is this a coincidence or a pattern? Are we glimpsing a galaxy teeming with cosmic nomads ejected from distant stars and hurtling through our neighborhood? The chilling truth is that our detection systems might only be catching the big, bright ones. Smaller objects could be slipping through, too faint for telescopes, but deadly to satellites. Every visitor forces us to rethink what's possible and what's at stake. For scientists, these objects are a goldmine, offering clues about the galaxy's diversity. For military planners, they're a wake-up call. Each visitor exposes gaps in our detection and response systems. Oumuamua revealed the need for better tracking protocols. Borisov highlighted our blind spots in chemical analysis. Now, 3I/ATLAS is testing our ability to adapt in real time. The Space Force's April 2025 adjustment might have been a dress rehearsal for a future where interstellar objects are routine, and not all of them friendly. If this pattern holds, the next visitor could arrive with even less warning, on a trajectory that threatens our space infrastructure. Are we ready? Let's explore the stakes, because they're bigger than you might think. Space is a dangerous place. A fleck of paint traveling at orbital speeds can crack a space station window. Debris from old satellites has forced astronauts into emergency shelters. Now imagine a fragment from 3I/ATLAS moving at 130,000 miles per hour, slamming into a billion-dollar satellite. GPS systems, communication networks, weather monitoring, all could be knocked offline in an instant. The Space Force knows this, which is why their SDA system is obsessed with tracking every object, no matter how small. 3I/ATLAS's debris trail, stretching millions of miles, is a nightmare scenario. Each particle is a potential bullet capable of shredding critical infrastructure. The April 2025 launch shift might have been a precaution, ensuring no Atlas V rocket crossed paths with this cosmic hazard. But what if it was more? What if the Space Force used 3I/ATLAS as a live test, practicing how to dodge an unpredictable threat? The SDA system can calculate collision risks in real time, but an interstellar object is the ultimate wild card. It doesn't follow familiar orbits. It arrives without warning, and its debris could linger, creating a long-term hazard. If the Space Force was training for this, they'd want to keep it quiet. Revealing their playbook could tip off rivals like China or Russia, who are watching America's space moves closely. The bigger picture is even scarier. What happens if the next interstellar visitor doesn't just pass by? Imagine a comet or asteroid captured by Earth's gravity, trapped in an elliptical orbit. Suddenly, every launch becomes a game of cosmic dodgeball. Commercial satellites, ISS resupply missions, lunar base deliveries, all could grind to a halt. The space economy, worth trillions by 2025, could freeze. And if an object comes too close, with too little warning, we might not have time to react. 3I/ATLAS was spotted just 3 months before its closest approach. The next one could give us days or hours. This is why the Space Force's silence matters. Classified data, precise trajectories, debris models, risk assessments holds the key to our preparedness. While NASA shares stunning images and scientific papers, the military is crunching numbers we'll never see. They're not just tracking 3I/ATLAS. They're gaming out scenarios where avoidance isn't an option. If you're wondering how close we are to a cosmic crisis, share your thoughts below, because the next chapter of this story could change everything. The Space Force's 2023 policy directive is crystal clear. Planetary defense and near-Earth monitoring are national security priorities. 3I/ATLAS wasn't just a scientific curiosity. It was a real-world test of America's ability to handle the unknown. By shifting that April launch, the Space Force might have been practicing for a future where interstellar visitors are routine. Every object teaches us something new: how to track unpredictable trajectories, how to predict debris fields, how to protect assets worth billions, but it also exposes our vulnerabilities. Our current systems track 35,000 near-Earth objects, but an interstellar visitor doesn't play by those rules. It's a wild card, a cosmic curveball that could upend everything. The pattern of interstellar visitors is unsettling. 3 in 8 years, each stranger than the last. Oumuamua's unexplained acceleration, Borisov's alien chemistry, now 3I/ATLAS with its impossible orbit and breakneck speed. If this is a taste of what's out there, the galaxy is far more chaotic than we thought. Smaller objects could be passing through constantly, invisible to our telescopes but deadly to our satellites. The Space Force knows this, which is why they're preparing for scenarios most civilians can't imagine. A visitor that doesn't just pass by but stays. A comet or asteroid that becomes a permanent neighbor, complicating every launch and threatening our space infrastructure. What's next? The lessons from 3I/ATLAS are shaping the future of space defense. New tracking protocols, upgraded radars, and classified algorithms are all in play. The Space Force isn't just reacting, they're anticipating. The next visitor could arrive tomorrow, next year, or a decade from now. When it does, it might not be as forgiving as 3I/ATLAS, which NASA confirmed poses no direct threat to Earth, but in space, no threat doesn't mean no risk. A single fragment in the wrong place could spark a chain reaction, taking out satellites and plunging our connected world into chaos. As we pull back the curtain on 3I/ATLAS, it's clear that our solar system is not the isolated oasis we once imagined. It's a bustling intersection on a galactic highway, frequented by travelers from distant stars. Each interstellar visitor, Oumuamua, Borisov, and now 3I/ATLAS, carries a story etched in its chemistry, its trajectory, its very existence. These are not just rocks or ice. They are messengers from stellar systems that may have burned out billions of years ago, or are still forming in corners of the galaxy we'll never see. The retrograde orbit of 3I/ATLAS hints at cataclysmic events in its past, perhaps a collision in a far-off star system, or a gravitational slingshot that sent it careening across the cosmos. Its carbon dioxide ice suggests it formed in a frigid void, far colder than the Kuiper Belt or Oort cloud. Every detail is a clue to a universe that is vast, dynamic, and full of surprises. But these visitors don't just bring knowledge, they bring risk. The Space Force's quiet maneuvers in April 2025 suggest they're preparing for a future where these cosmic nomads are regular guests, each one a potential hazard to our increasingly crowded orbital highways. The question isn't just what we can learn from these objects, but how we'll survive their visits. If this cosmic perspective excites you, share your thoughts in the comments. What do you think the next visitor will reveal? Behind the public spectacle of 3I/ATLAS lies a shadow world of classified operations. The Space Force's Space Domain Awareness System is a technological marvel capable of tracking thousands of objects with pinpoint accuracy, but its true power lies in what it doesn't share. While NASA releases breathtaking images and scientists publish papers on isotopic ratios, the military's radars are collecting data we'll never see: precise velocity profiles, fragment dispersion models, structural integrity estimates. This isn't just about curiosity, it's about survival. A single miscalculation could mean the loss of a satellite that guides military operations or powers global internet access. The April 2025 launch shift, cloaked in vague excuses, might have been a response to early SDA detections of 3I/ATLAS, long before its public discovery. If so, it reveals a chilling reality. The military is always one step ahead, watching for threats the public doesn't even know exist. This secrecy is a double-edged sword. It protects national security, but leaves us wondering how much we're not being told. Are there other objects out there, too small or faint for civilian telescopes, already on the SDA's radar? The silence around 3I/ATLAS suggests a bigger game at play, one where interstellar visitors are both a scientific windfall and a strategic challenge. What do you think the Space Force isn't telling us? Drop your theories below, because the truth might be closer than we realize. The arrival of 3I/ATLAS is a turning point, a moment where science and strategy collide in the vastness of space. It's a reminder that our future in the cosmos depends on our ability to adapt to the unexpected. The Space Force's actions in April 2025, whether precautionary or experimental, signal a shift in how we view our place in the universe. No longer are we just explorers, peering through telescopes in search of knowledge. We're defenders, tasked with safeguarding a space-based infrastructure that underpins modern life. The lessons from 3I/ATLAS will shape the next generation of space defense. Smarter algorithms, more sensitive radars, faster response protocols. But they also force us to confront a humbling truth. The galaxy is indifferent to our plans. Interstellar visitors will keep coming, each one a test of our ingenuity and resilience. The next could be a harmless wanderer like 3I/ATLAS, or it could be a rogue object on a collision course with our satellites, or worse, as we stand on the cusp of a new era in space exploration, with lunar bases and Mars missions on the horizon, the stakes have never been higher. 3I/ATLAS is a wake-up call, urging us to prepare for a future where the line between science fiction and reality blurs. So, what's your take? Are we ready for the next cosmic visitor? Or is the galaxy about to throw us a curveball we can't handle? Share your thoughts in the comments, and let's keep exploring the mysteries of the universe together. Imagine the intricate ballet of satellites, space stations, and rockets orbiting Earth, each following a precise path choreographed by the laws of physics. Now introduce 3I/ATLAS, a rogue dancer crashing through this delicate performance at 130,000 miles per hour. Its arrival disrupts the rhythm, scattering debris that could turn this cosmic waltz into a catastrophic collision. The Space Force's April 2025 launch adjustment might have been a calculated step to avoid this chaos, ensuring their Atlas V rocket didn't cross paths with a stray fragment. But the implications go far beyond a single launch. Our orbital environment is already crowded, with over 35,000 tracked objects, satellites, spent rocket stages, and debris zipping around Earth at speeds that make a bullet seem sluggish. Adding an interstellar comet's unpredictable debris trail to this mix is like tossing a grenade into a clockwork mechanism. Every fragment from 3I/ATLAS, even one as small as a marble, becomes a hypervelocity threat, capable of punching through a satellite's hull or shattering a solar panel. The Space Force's Space Domain Awareness System is designed to predict these risks, but an interstellar object like 3I/ATLAS introduces variables that defy standard models. Its retrograde orbit and high speed mean it doesn't follow the familiar paths of near-Earth asteroids, forcing planners to rewrite the rules of orbital mechanics on the fly. If the April shift was a test, it was a high-stakes one, preparing for a future where every launch must account for cosmic wildcards. The fragility of our orbital infrastructure, GPS networks guiding global navigation, communication satellites powering our digital lives, weather systems forecasting storms, hangs in the balance. One wrong move could trigger a Kessler syndrome event where a single collision sparks a chain reaction of debris, rendering low Earth orbit unusable for decades. The question isn't just whether we can track 3I/ATLAS. It's whether we're ready for a future where such visitors are routine, each one threatening to upend the delicate dance of our space-based civilization. What do you think? Are we prepared to protect our orbital highways, or is 3I/ATLAS a warning we're not taking seriously enough? Share your thoughts below. Every interstellar visitor is a chapter in the galaxy's ancient story, and 3I/ATLAS is no exception. Its composition, rich in carbon dioxide ice with isotopic ratios alien to our solar system, suggests it was born in a stellar nursery vastly different from our own. Perhaps it formed in the icy fringes of a dying star, or amidst the violent churn of a binary system where planets never had a chance to coalesce. Its retrograde orbit hints at a dramatic ejection, perhaps flung from its home system by a gravitational tug of war billions of years ago. As it races through our solar system, it's not just a fleeting guest, it's a relic of cosmic history, carrying clues to events that predate our sun. Scientists are racing to decode these clues, analyzing every spectral line from its glowing coma, every particle in its tail. The data could reveal not just where 3I/ATLAS came from, but how the galaxy itself evolves, how stars are born, how planets form, how matter scatters across the cosmos. Yet this scientific treasure trove comes with a shadow. The same debris that holds these secrets could become a weaponized hazard, threatening our satellites and space missions. The Space Force's April 2025 maneuvers suggest they're not just watching the science, they're preparing for the practical fallout. If 3I/ATLAS's debris trail lingers, it could haunt our orbits for years, a ghostly reminder of its passage. This duality, scientific wonder and strategic threat, defines our relationship with interstellar visitors. They're a bridge to the galaxy's past and a challenge to our future. As we study 3I/ATLAS, we're not just learning about distant stars, we're learning about ourselves, our vulnerabilities, and our resilience in a universe that doesn't care about our plans. What do you think this cosmic history lesson means for us? Is 3I/ATLAS a gift of knowledge, a warning of danger, or both? Drop your thoughts in the comments, because this story is far from over. Let's bring it full circle. The discovery of 3I/ATLAS on July 1st, 2025 wasn't just a scientific milestone, it was a wake-up call, a reminder that our solar system isn't a quiet cul-de-sac, but a busy cosmic highway with visitors dropping in unannounced. The Space Force's cryptic launch shift in April, timed perfectly with the comet's approach, suggests they're playing a bigger game. Whether it was a precaution or a strategic test, it shows how seriously they take these interstellar intruders. The galaxy is full of wanderers. Ancient comets, rogue asteroids, fragments from distant stars. Some are harmless, some could change everything. As we speak, telescopes worldwide are tracking 3I/ATLAS, decoding its chemistry and unraveling its story. But behind closed doors, military planners are doing their own calculations. They're not just watching the skies, they're preparing for a future where the next visitor might not be so polite. The stakes are immense. $1 trillion space economy, global communications, national security. One wrong move, one untracked fragment, and the consequences could ripple across the planet. So, what's the takeaway? 3I/ATLAS is more than a comet. It's a glimpse into a chaotic, unpredictable universe. It's a challenge to our science, our technology, and our readiness. The Space Force's quiet moves in April 2025 hint at a world where cosmic threats are taken seriously, where every visitor is a chance to learn, adapt, and prepare. The next one could be closer than we think, carrying secrets or dangers we can't yet imagine. What do you make of this cosmic mystery? Was the Space Force's launch shift a coincidence or a calculated response to an interstellar wildcard? Drop your thoughts in the comments. And if this story of science and secrecy hooked you, give it a like and subscribe for more. The universe is full of surprises, and we're only scratching the surface. Stay curious, because the next visitor might just rewrite everything we know about our place in the stars.